In section 4, we're taking a look at the surface area of prisms and cylinders. So the surface area is just all of the area of each side of the shape added up together. If we're looking at a prism, you're going to have two bases and then the remaining faces added together. Or if you're looking at a cylinder, you're going to have the area of each base and then the area of the piece that goes around the cylinder. So let's look at the first one here with a rectangular prism. So this is very basic. Each side here is just a rectangle. So we just need to piece that together. We have two sides that are going to be 12 by 6. So I have two sides that are 12 by 6. Then I have two sides, the top and bottom here, that are 6 by 8. And then I have two sides that are going to be 12 by 8. So kind of the front and back, I suppose you could say, are going to be 12 by 8. You're basically just pairing up each set of numbers out of those three numbers. And there are two of each of them, so we're going to do 2 times 12 times 6 plus so on. When we do that, we end up with 432, and it's going to be centimeters squared. We're still talking about area, so area is two-dimensional, which means our units are going to be squared. If we're looking at a prism that has a different kind of base, we're going to get the area of the bases, and then we'll worry about the area of the rectangles that are the other faces of this shape. So let's start with the hexagon here. Now, in order to find the area of a hexagon, it's a regular hexagon, and so we're doing 1/2 the apothem times the perimeter. And so let me kind of redraw this triangle a little bit so it's a little easier to see. If the side length of the hexagon is 6, that means when I create my right triangle that this is 3. I'm looking for the apothem. This is a hexagon, so the central angle, remember we do 360 divided by the number of sides, so we're dividing by 6, so that's 60. So the central angle would be 60. This entire thing would be 60. We're only looking at half of that, so this is 30 degrees. This is going to be a 30, 60, 90 triangle. If you remember your rules for that, you can use that. If not, you can do the tangent of 30 degrees equals opposite over adjacent, 3 over A. So we're going to take 3 divided by the tangent of 30 degrees, which is going to come out to be 3 times the square root of 3, which is the same thing you would get if you use your 30, 60, 90 rules, going from the short leg to the long leg, you multiply by the square root of 3. So that's the apothem. So we can find the area of our hexagon by doing 1/2 the apothem, so 3 times the square root of 3, times the perimeter. The perimeter of my hexagon, if we have 6 sides that are 6 inches, that's going to be 36. If I multiply that all out, I'm going to end up with 54 times the square root of 3. So that would be the area of one of the hexagons. Now let's look at these rectangular sides along there. Each of those sides is the same because it's a regular hexagon. Each of these is going to be a 10 by 6 rectangle. So one of them, the area is just going to be 10 times 6, which is 60. Now, in order to get my surface area, I just add up each surface, each face of the prism. We have 2 hexagons, so I have 2 that are going to be 54 times the square root of 3. And then I have 6 rectangles. If there are 6 sides to the hexagon, that means there are 6 rectangles there connecting those two hexagons. So I have 6 rectangles that are 60 each, and so if I combine those together, that's going to come out to be about 547.1 inches squared. So add the bases, add up all of the other sides of the shape, and that gives you your surface area. With the cylinder, you're going to have 2 circles, and then you actually end up with a rectangle as the other part of the shape. If you think of a piece of paper, if you roll a piece of paper up, it can look like a cylinder. Well, it started as a piece of paper, which is a rectangle. So we're going to have two circles and a rectangle making up the surface area of the cylinder. Let's start with the circle part of this. The area of a circle is pi r squared. So we're going to have pi times, if our diameter is 2, then the radius is going to be 1. So pi times 1 squared is just going to be pi. In order to get the rectangle part of this, so think of unrolling the cylinder. When you unroll that, the part that went around, like it went around in a circle there, the distance around the circle is the circumference. So we're going to be doing the circumference. So in this case, the circumference is going to be 2 pi. So this is the circumference of this. And we multiply then the circumference by the height of the cylinder. So the 5 there. So that's going to give us 10 pi. So anytime you're working with a cylinder, to get the area of that part that goes around, that rectangular part there, you're going to take the circumference times the height of the cylinder. So then to get my surface area, I have two bases, so two circles that the area is pi, and then I have the area of that rectangular portion, which is 10 pi, so this is going to come out to be 12 pi. We could get the decimal equivalent here as well, but it's going to come out to be about 12 pi meters squared, or exactly 12 pi meters squared. Let's do another cylinder. This time the circumference is 10 pi, and a height is going to be equal to 3 times the radius. I know my circumference is 10 pi. If that is the case, that means my diameter is 10, which would make my radius 5. So then if the height is equal to 3 times the radius, the height is going to be 3 times 5, which is 15. Now I can use that information to calculate the area of the bases. So the base is going to be pi r squared for the area there. So we have pi times 5 squared, which is going to be 25 pi. Remember, the other part of it is a rectangle that you unroll. The length of the rectangle is going to be the circumference, so 10 pi. And then we multiply that by the height of the cylinder, which is 15. So if this is the portion that we unrolled, the length of this rectangle was 10 pi, and the height was 15. And so if we multiply that, we're going to end up with 150 pi. So now we need to finish getting the surface area by adding up each of the bases and faces here. So we have two bases that are 25 pi, and then we have the rectangular portion that is 150 pi. So that's going to be 50 pi plus 150 pi. That's going to be 200 pi. And in this case, we don't have units, so I'm just going to leave it as 200 pi. Let's look at one more. This is a composite figure, so meaning we put two different three-dimensional shapes together. And in doing so, we've covered up the bottom of this triangular prism and the top of this rectangular prism. If it is covered up, then we don't count that as part of the surface area. So we're not going to be counting the bottom of the triangular prism or the top of the rectangular prism. Let's start with the rectangular prism. So the rectangular bottom of this figure that we have one side that is 4 by 2. That bottom is 4 by 2. So I'm going to have a 4 by 2 spot there. So that's 8. The two sides are 3 by 2. So 3 by 2 is 6. I have 2 of those, so that's going to give me 12. And then I also have this section that is 3 by 4. So it's 3 high by 4, so the front and back are 3 by 4, which is 12. We have the front and back showing on both of those, so there are 2 of those at 24. If I add those up, 24, 12, and 8, that gives me 44. So that's the surface area of just that rectangular prism part at the bottom. Now let's look at the triangular prism. Here we're going to have 2 triangles. The triangles are 3 by 4 as the base, because it's going to match what was down below. So we have a triangle that is 3 by 4, so the area of the triangle is 1/2 base times the height. So 1/2 of 4 times 3, that's going to give me 6. There are 2 triangles showing front and back here, so that's going to give me 12 altogether. Then I have on the left-hand side here, this is 3 by, if we're looking from going front to back, if I find that dimension, this is 2, which means this was 2, which means this here is 2. So I have a 3 by 2 rectangle over there, which is going to be 6. There's just one of those. And then I have this flat surface that's slanted on the side here. I know that it's like too deep. If we're going front to back here, it's too deep. But what I don't know is this portion right here. I can do Pythagorean theorem, or if you recognize your Pythagorean triples, this is a 3, 4, 5 triangle. So this rectangle that is slanted is going to be 5 by 2, which is 10. If I add those up, these are going to come out to be 28. So then my total surface area from the bottom, the 44, and the top portion of this, the 28, is going to be 72. So the surface area here is 72 square centimeters.